welcome back, everybody. We are going to work on factoring. I love factoring. It's one of my favorite things to do. To start off with, we're going to work on factoring the greatest common factor. Finding polynomials whose products equal a given polynomial is called factoring. A polynomial with variable terms that cannot be written as a product of two polynomials of a lesser degree is a prime polynomial, kind of like a prime number. A polynomial is factored completely when it is written as a product of prime polynomials. So that's some of the vocabulary that we have learned in the years, just refreshing that. A couple of things to remember. Factoring solutions may always be checked by multiplying the factors together. So in R.3, we worked on multiplying polynomials. And so we can use that skill, multiply the factors together to see if we get the original polynomial that we factored, what we started with, back. All right, so we're going to start with greatest common factor. The greatest common factor is the largest number and or variable that we can divide all terms by. So if you look at 9y to the fifth, and that's 1y squared. So largest value that we can take out for the letters is the smallest exponent. Our smallest exponent is y squared. We can divide both of these by y squared. We have enough to pull out. We write what we're pulling out, and then we write a parenthesis, and we write the leftovers. This is 1y squared. 9 divided by 1 is 9. I have 5 y's. I'm taking 2 of them out, so I'm left with 3. We still have this plus sign. So even though the y squares simplify out, they do technically, because we're dividing, simplify to 1. And we do have to write that down. So y squared times 9y cubed plus 1 is our answer for factored form. This is our greatest common factor, and these are what we call the leftovers from when we pull that out. If I come to letter B, I want to start with 6, 8, and 12. What's the largest number I can pull out of all of those? Well, they're all even numbers, so I know I can pull out a 2. And then we have x, but there's no x in this third term, so I can't take out an x. They do all have a t, though, so I can pull out a t. So 2t is our GCF. 6 divided by 2 is 3. The x squared. The t's reduce out, and there's no t's left. Then we have a plus sign. 8 divided by 2 is 4. We have the x. The t's reduce out. Plus 12 divided by 2 is 6. The t's reduce out, so we just have 6 left for that last term. So this is our factored form. All right, letter C, they're trying to get a little tricky here. I'll start with the numbers. We have 14, 28, and 7. They all have a factor of 7. So we know we're pulling out a 7. And then if you notice in the parentheses, all 3 parentheses have an m plus 1. So m plus 1 is the other part of that greatest common factor. So our leftovers, we start over here. 14 divided by 7 is 2. We had 3 m plus 1s. We're pulling just one of those sets out. So that leaves us with m plus 1 squared minus 28 divided by 7 is 4. This had 2 sets of m plus 1. We're pulling one of them out, so we're left with one set of m plus 1s. Minus 7 divided by 7 is 1. And the m plus 1 we pulled out. And so there is our factored form. Factoring by grouping. So our goal is to make these rearrange if we need to. We don't always need to rearrange it. So that we can group 2 sets together, or sometimes 3. So that way they are factorable. 2 things about this. First, you can rearrange terms. So common terms are near each other. And our steps, first, this is an if needed, we would rearrange. And that's an if needed. Second, split terms in half. Third, find GCF and leftovers for each half. Fourth, when we do that, we would have a new GCF and new leftovers to finish factoring. So that's kind of how we're going to take a look at it. So I'm looking at letter A, and I see that the first 2 have an M in common, but the last 2 have nothing. Well, they have a 3. So we could rearrange these for the p squares to get put together, or we can just leave it alone. As long as each set that's sitting next to each other has something in common, and they do. So I'm going to go ahead and split this right down the middle. And I start with the common factor over here on the left side of my split. Well, they both have an m. When I pull m out, I'm left with p squared and then a 7. So p squared plus 7. On the right side, I have a common factor of 3. So when I pull 3 out of 3p squared, we're left with p squared plus 21 divided by 3 is 7. Well, that's great because look at p squared plus 7 is now the same on both sides of my split. That is our new GCF. So p squared plus 7 is our new GCF that we're pulling out. And we're left with m, and this is a positive 3 because of the plus 3 there. M plus 3 is left over. That is my factored form. All right, letter B. Well, if I were to split this in half right now, the left side has nothing in common and the right side has nothing in common. So I wonder if I flip-flop these, if that would help. Well, let's try it. Let's rewrite it as 2y squared minus 2z plus az minus ay squared. Well, that's closer. I think I need my y squared to come before my az. So let's try one more time. So I see y squared z, y squared z. All right. Now that I've rewritten it, I'm going to go ahead and split it in half down the middle. On this left side, they have a common factor of 2. That leaves me with y squared minus z. We always start the next part with whatever sign is in front of the second half. So there's a minus sign, so we're pulling out a minus. These both have a common factor of a. Now be careful because this means we're dividing by negative a, which is going to change our signs. Negative a over negative a leaves a positive y squared. Positive a over negative a leaves a negative z. Well, this is exactly what we wanted to have happen because look, we now have a new common factor. Both sides have y squared plus z. So y squared minus z. Y squared minus z is my new common factor. And 2 minus a is left. Let's see. Letter C. We have some like terms and some not like terms. Let's see if we can leave this alone without rearranging it. I'm going to erase the stuff underneath. Actually, that makes it faster. All right, so if I split it down the middle, the left side, 4 and 2 have a common factor of 2. We have 3 x's and 2 x's, so I can pull out 2 x's total. 4 divided by 2 is 2. I had 3 x's. I'm taking 2 of them out, so I'm left with an x. Plus, remember, we always have to have both terms there, even though technically 2x squared over 2x squared reduces out. But remember, we're dividing. So 2 divided by 2 is 1. The right side starts with a negative. Now, these don't have any common terms. However, you can always pull out a 1. You can always pull out a 1. But I want it to be negative 1 because it starts here. So if I pull out a negative 1, that means I'm dividing both sides by negative 1. Negative 2x divided by negative 1 is a positive 2x. Negative 1 divided by negative 1 is a positive 1. Well, again, look at what happened. We have 2x plus 1 and 2x plus 1 as my new common factor. And when I pull those out, I'm left with 2x squared minus 1. And so that would be my factored form. This is where we're stopping for today. Thanks so much for joining me. Have a good evening.